This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is our second video on graphing the secant function, and we're going to graph y equals negative 1/2 secant of x on this video. So here's the technique I'm going to use. I'm going to graph y equals negative 1/2 cosine of x and draw my asymptotes. And then note that the maximum and minimum points of the cosine graph that I draw will switch for the secant graph. So we want to graph y equals negative 1/2 secant of x, and note that will be the same period as for y equals negative 1/2 cosine of x. So note the period will be what? Well, for y equals negative 1/2 cosine of x, the period is 2 pi, so that will also be true for the secant. So let's see. That means we probably want this to be 2 pi, this to be negative 2 pi. And then I note that the coefficient here is negative 1/2. All right, so that is going to be either the minimum or maximum value of the secant or cosecant, depending, the secant or the cosine, depending on which one we're doing. So how about if I label this one and this negative one? That way it's easy to see where the 1/2 is. All right, there's another thing going on here, the minus sign. So we got to be careful there. So cosine usually starts up here at 0, 1, right? So when you put in 0 for x, you get 1. But you're doing negative 1/2 times that. So that starts down here instead at negative 1/2, right? Negative 1/2 times 1, it starts down here. So basically, it starts down as opposed to up. It starts negative, and it comes up through here. And here's where it ends up being positive 1/2, and then going down. And that is one period. Now, if you kept on going, go a little bit further. I like to kind of finish it off. I like to see a whole two basic shapes like this, right? Like half circles. And then same thing over here. Just keep going. And we have the graph of y equals negative 1/2 cosine of x. Remember, if it was positive 1/2, it would start up first. But it's negative, so it starts down. Next thing we have to do is do our vertical asymptotes. So remember, we're taking the reciprocal of what you see on the for the y values, and anytime the secant, anytime the cosine crosses the x-axis here, then we've got a y value of 0, but the reciprocal of 0 is undefined. So I need to draw vertical asymptotes right here, anywhere it crosses. Etc. So we have to think of at least what one of those are. All right, this is pi over 2, right? Remember how it goes? Pi over 2 pi, 3 pi over 2, 2 pi. So one of the vertical asymptotes is pi over 2. So remember, it is an equation. It's a line, right? It's a vertical line. X equals pi over 2. And now to get to the next asymptote, you add half the period, right? Because you go two places to get a whole period, right? You see there's a vertical line in between the beginning and end of a period. So it will just be plus half the period. All right, well, if the period's 2 pi, half the period is pi. It's a multiple of that. Now, if you want, you could always get a common denominator. That's up to you. K is an integer. Some people like to think of getting that a common denominator. So you could write 2 over 2, but so just keep in mind, some people might write x equals, if you got a common denominator, it would be pi plus 2 pi k all over 2. I don't know. That to me doesn't look any easier. You can't combine the pi and the 2 pi anyway because of this k. So you could also do that though, but it's not wrong. Just another option. So we've got our vertical asymptotes. We have our period. Let me write that period down here again. The period was 2 pi. Now we haven't graphed the function yet, But after we do, we're also going to put the range as well. Those are the three things we definitely want to state. The period, the range, and the vertical asymptotes. All right, so how do we graph negative 1/2 secant of x? I have in the dotted line, I've graphed y equals negative 1/2 cosine of x. Well, the maximums you see for the cosine are the minimums, and so we just get to draw these nice little pictures like this. You don't have to get any more accurate than that. Just make sure that you're making them rounded and they're not parabolas. They cannot cross. Make sure they kind of start going straight up as much as possible. They're getting close to that, but not exactly touching or crossing the vertical asymptotes. So there we go. What's our range going to be? Well, for the secant and the cosecant, it goes down forever and it goes up forever, but there's this little part in the middle between two numbers where there aren't any values. Like in this one, it's between negative 1/2 and a half. So we've got negative infinity up to negative 1/2, right? And including that. And also, we get to start again at 1/2. These are what the y values are, the range. 1/2 going up all the way to infinity. And so there we have it. We've graphed y equals negative 1/2 secant of x. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.